Hello everyone. Good morning. We'll be dealing with the submerged part of slope stability today. That's using the Swedish method of slices. Yes. So we'll be considering a simple question with a submerged level of about 4 meters and a side slope of 1 vertical to 2 horizontal. So you can see the question. So let's begin. So looking at this dimension, we can see that the height from the base of the slope to the top of the slope is about 11 meters. Then from that top of the slope to the point where the radius of the slope is another 7 meters. That means the total vertical height to the point of the radius is something around 18 meters. And for the horizontal, from the toe to the top of the slope is going to be something about 16.5 meters using the ratio of the slope. So we don't know what xm is going to be. That means we have to make allowance for it. So let's say that one will be about 7 meters. So 7 plus 16.5, that's about 21 meters. So the reason for saying all this is because of the kind of graph that we have, so that we'll be able to tell the scale to use. So on this graph now, I know for one that this might not be able to take 20 meters. Yes, that's 20 centimeters. So I'm going to be using my 1 centimeter here to represent 2 meters. Yes. So that means for every 1 centimeter I have, it's going to be 2 meters. So, like I said, I'm going to be representing my 2 meters with just 1 centimeter. So that means by the time I measure 10 centimeters, I'm already representing 20 meters. So you guys know how to represent that scale. So let's start. So to draw my first horizontal line, I'll be starting from this base here. So far you know what you're expecting, you can actually start from anywhere. So I'm just drawing this. So I'll try as much as possible to make the lines very deep. Yeah. So from here now, I want to measure 18 meters up. So, and to measure 18 meters from the scale, that means I'm going to measure 9 centimeters to the top. So I'm taking it from this point, 9 centimeters. Sorry, this ruler is okay. 9 centimeters. So this is where my 9 centimeter gets to. So with a better ruler now, we can confirm our 9 centimeter appropriately. Okay, it appears our 9 centimeter is 9 centimeter. So good for us. So for the other part, where the radius is going to be from the diagram, which I believe you can see on the screen, we have 5 meters away from the toe, which is going to be 2.5 centimeters on our graph. So whatever it is you have in real life, just divide by 2 and change it into centimeters. So 2.5 is somewhere around here. Yes. So finally, we've been able to mark our point O. So we can call it point O for the center of the circle, of the slip circle. So from here now, we have to mark our 11 meters also, which is going to be 5.5. I believe you still remember why we have to do that. 5.5 is around this point. So from here now, I can transfer my line. Yes, just transfer the line. The line is faint, so it might not be really visible. But if you are following and you are measuring, you won't have a problem. So from there, working by the ratio 1 equals to 11. That means x be, so 1.5, sorry, will be equal to x. So doing the cross multiplication, x equals to 1.5 multiplied by 11. So from the calculator, 1.5 multiplied by 11 gives us 1.5 times 11. That's 16.5, like I've said earlier. So on this line now, we are going to measure 16.5, but mind you, we have to divide by 2. So that's 8.25. 8.25, yes, it is directly on this point. So we can now draw our slope to join this. So I believe I can make this one as thick as possible so that you can see it. Yeah. Okay, yeah, it's visible. So and also from here, I can make this one thick. Yes. Okay. So from here now that we've drawn the slope and we've been able to put all the necessary parts, we already know the location of the radius. What we need to do now is to draw the arc. Since we know the radius is going to touch the toe and it's going to touch a particular point at the top. So while I try to set my pencil with the compass, I want to remind you that in some cases you might not be given a direct question like this. So telling us the position where the radius is going to fall. No, in some questions it might not be that way. So there is another case in the previous video, like the question in the previous video, the one that is not submerged. So that particular one, we're not given the point, but we're given the distance from the top of the slope to the level. So through that, we were able to calculate our length of arc and get the point where the radius will fall. So you can just rewatch the video on slope stability using Swedish method. So now let's draw our arc. I've gotten the radius. So one of the reasons why it is important to use a good scale is because of when you have to draw your arc. For most people, their compass can extend more than 11 centimeters. Now, imagine what we were drawing was times 2 of this. So that means we need a bigger compass, and which most people don't have access to. So it's better you think about what you want to draw first before you choose any skill. And always remember to label your work. So for the sake of clarity now, I'm going to use pen. I'm going to continue labeling with pen. So I've called this place point O. Or better still, let me just use a pencil because it's going to show. So let me call this one point A. So I'll call this point B. Then let me call this C. So, and from here, we can now draw the slip sector, like since it's not an entire circle. So we can just draw the sector out by completing the two radii by the side. So, and it is from here that we can now find out what our radius is going to be. Although mathematically we can do that by using Pythagoras theorem. So since we are dealing with construction, we can as well make use of construction, because going by mathematics now, to get our radius, all we just need to do is to do 18 squared plus 5 squared and finding the square root, which is 18.68. But because we are dealing with construction, so it's better to just measure and see whether what we have is actually right or not. So currently now, from my measurement, I have 9.3. So multiply 9.3 by 2. 9.3 multiplied by 2 is going to be 18.6. So it's close enough to what mathematical calculation gave me. So I believe we can continue. So the next thing left for us to do is to measure the angle of the slip surface, not angle of internal friction now. I'm talking about theta. So theta here equal to. So making use of the protractor, let me try to get what my angle is going to give me. So um, each one of us must learn to use our protractor very well. So the angle I'm getting from here now is 83 degrees. Yeah. If you can zoom into the video, you will see that it's directly on 83 degrees. So, which is close to what mathematics should give me also. So let me write it. Theta equals to 83 degrees. So my radius is 18.6 meters. That's the radius. Okay, so now that we are done with this, we are to find the length of BC. So let's try to measure once again the length of our BC. So what I have here is 2.9, 2.9, and 2.9 multiplied by 2. Oh well, it's not directly on 2.9. This is like 2.87 or 2.88. So, and 2.88 multiplied by 2. 2.88 multiplied by 2 gives 5.76. So let's say 5.8. which is still the same as 2.9. So the distance here now, here, making use of the ruler, is 5.76 meters. So I believe we can work with that. So the next thing for us to do, and which is a very important part of the tutorial, is to mark the point of the slope being submerged. Yes. So, and from the question, we are given that at a depth of 4 meters, it's completely submerged. So, we have to mark that 4 meters. And from our scale, that's what you guessed it, that's 2 meters. So, at point 2 meters, we have to draw. I'm going to make the line thick to be as visible as possible. So, yeah, that is the point, which is 4 meters. So, we can try to label and dimension our drawings for the purpose of clarity and openness. If you understand what I mean. So, here, so here is 18 meters. Here is, oh, the whole length is 18 meters. Here is 4 meters. So this place can be 18. So this is now 14 meters. So from here now, all we are left to do is to start dividing. So we need to start to divide. So if we decide to use, how many slices can we even have? Let's measure the total length so that we can guess or estimate the number of slices we are expected to have. So according to the rule, we are not supposed to have less than 6 slices and more than 12 slices. So let's try to measure the length from the beginning of the curve to the end, the horizontal length, I mean. So we have 11.1. Yes, we have 11.1. So that means we can actually divide by, let's say, 1 centimeters. Yeah, 1 centimeters. We can divide by that. And the last one is going to be 1.1. So and mind you, we using 1 centimeters, it simply means we are dividing by 2 centimeters because of the scale. So that's get one of the points because it is very easy here to encounter or calculate it. Okay, for the last one. So at the same time, let me quickly mark the center point also. So I'm going to speed this process up to save time. So mind you, you're working against time in the exam hall. So whatever you do, even if it's um, 10 slices or you want to make use of 6 slices, be fast with them. So now all I need to do now is to start drawing the lines. Mind you, the line must touch the top of the slope. It must touch the slope and the curve. Yes. So I believe my lines are clear enough. Clear. So what I have is this. And looking at what I've drawn, you see that in the process of trying to make the line meet the point we have marked, I extended it, making it cross the curve. Well, that one, there's no penalty for that actually. So the only place where you can make mistake is when you are trying to draw a line from the center point to the centers of those lines. So let's draw those lines. Remember, this one has to be dotted. So we are done with that. And the next part now is to start joining our lines from zero, that's point from point O to the where the lines, the dotted lines touch the arc. So the ones on this side are going to be negative, while the ones that fall to the other side are going to be positive. So that's a good question. When you see is there so this one is 0 degrees. Okay, so looking in properly, you would see that I've written or I've drawn the lines. So the next part to solving this question is trying to draw our tables. So, and for the table, we have various parameters that we'll be considering. So, one is to label, we can decide to label our slices. So, this is one, we have 11 slices. Two, let me use a thicker pencil. Three, four, five, six, seven, eight, nine, 10, and finally 11. So, going to the table now. So this part is for the slice. Then so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, finally 11. So the next one is going to be for the height. So and for the height, we have different heights. So we have the submerged height and we have the unsubmerged height. So we can decide to call the submerged height H1 and the unsubmerged height H2. So that means we have two columns here, H1 and H2. So this H1 and H2 can also be in a single column, but to reduce confusion, it is better and it is advisable to separate them. So H1, H2. So let's start filling in our H. For the first one, let's measure. So the first one is totally submerged. And what I have here now is 0.4. 0.4. So that means it is 0.8. 0.8. So the H2, we don't have anyone above. So for H2 now, it's going to be dash or put 0. So let's go to slice number 2. So for the second slice, our H1, which is totally submerged to, is about 1.12, that's 1.1, 1.2, 1.3. So that's 1.3 multiplied by 2. That's 2.6. 2.6. Then for H2, we don't have a value. So for the third one, so going to the third one, so here now I'm measuring 2, that's 4. 4.0, there is no 1. Then now moving to the fourth slice, we can see some parts are submerged while some parts are not. So the submerged part, me measuring it now, I have 2.1, 2.2, 2.3. 2.3 is going to give me 4.6, right? Yes, 4.6. While the other part that is not submerged is 0.1, 0.2, 0.3, 0.38. It's about 0.38 or 0.36. So 0.36 multiplied by 2, that's 0.72. 0.72. So that's done. Now moving to the fifth slice, which has both submerged and non-submerged. So I have 2.1. 2.1, that's 4.2. Yes, 4.2. And the unsubmerged part, that's the saturated part or the bulk part, that's 1, which is 2. Yes, 2. So moving to slide 6, I'm going to speed this up. The submerged part is 1.1, sorry, 1.6, 1.7, 1.8. 1.8 times 2, that's 3.6. Yes. And for the submerged part, unsubmerged part, we have 1.6, 1.7, that's 3.4. Yes. So for slice 7, we have, this is 1.45 multiplied by 2. 1.45 times 2 gives us 2.9. Is 2.9 for slice 7. And for the second one, slice 7, 2.35. 2.35 times 2, that's 4.7. Yes. So for slice number 8, which also has a submerged part, I have 0.9, that's 1.8. 0.9, that's 1.8. Or let's confirm again. Slice number 8. Yeah, 0.9, that's 1.8. While the other part, which is submerged, or not submerged, sorry, has 3.0, 3.03. 3.03 times 2, that's 6.06. Okay, 6.06. So to the ninth one, which has a teeny bit of submerged, that's 0.15. 0.15, that's 0.3. No, 0.15 times 2 times 2, 0.3. Yeah, 0.3. Wow, the bigger part for slice 9 is 3.5, which is 7. Okay, and to the 10th one. The 10th one is without the submerged part. That's 2.5, 2.6, 2.65. 2.65 times 2. That's 5.3. Now to the 11th one, without the submerged also, we have 1.1, which is 2.2. 2.2, yes. So for the width, we can assume the widths are of the same thing, but the last one is not the same. So we have W, yes. Calling the width small letter W, while the width is capital letter W. So for the width now, we made use of 1 centimeters. That's the same thing as 2 centimeters, right? Yeah. So 2 centimeters. So- Okay, last one is actually two. That's 1.1 multiplied by 2. Yes. So let's confirm again. That's 2.2. The last one is 2.2 centimeters, which is not the same as the others. So we can now move to our area 1 and area 2, which is A1 and A2. So we'll be limiting ourselves to two decimal places for the sake of space. And any place where we can go more than that, no problem. So here it's just going to be purely calculations. So you have dash, 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 here, dash, dash. So 4.6 times 2, that's 9.2. 9.2, 4.2 times 2, 8.4, 3.6 times 2, 7.2, 2.9 times 2, 5.8, and then 1.8 times 2. That's 3.6. 3.6. Here is 0.6. Yeah. And 5.3 times 2. That's 10.6. Then 2.2 times 2.2. That's 4.84. Okay. So for the other side, 9.2 times 2, that's 18.4. 8.4 times 2. Oh, sorry, this is a mistake. This should be 0.72 times 2. That's 1.44. That's 2 times 2, 4.0. Then 3.4 times 2, 6.8. Then 4.7 times 2, that's 9.4. And 6.06 times 2, that's 12.12.
What name can I call this band? Is it any food or what?
Swallow.
Swallow.
7 times 2, from 0. So everything looks in order. Now to find our W. So we also have W1, which is A1 gamma sub, and we have W2, which is A2 gamma sat. So from the question, we'll be given our submerged unit weight and our saturated unit weight. So in case you're not given, you might just be given the one for sub, and you know that to get for sat, you just add the unit weight of water. And in case you are given the one for sat, just subtract the unit weight of water from it to give you the out of it. So according to this question now, we know that our gamma sat equals to 18 kilonewtons per meter cube. Then gamma sub is 8 kilonewtons per meter cube. So we can continue from there. Okay, better still. This is the gamma bulk. That's it could be bulk, it could be sat. Because I think one of the assumptions is that the soil is saturated, so it can be bulk, it can be sat. So, well, in any case, you just have to subtract the unit weight of water to get the submerged. Thank you. And moving on, let's calculate W1 and W2. So, bulk. So for the W1, that's area 1. Oh, yeah. We are yet to even finish calculating this. 1.8 times 2. 1.6. 2.6 times 2. 5.2. 4 times 2. 8.0. Okay. So we have 1.6 times sub 8. That's 12.8. 12.8. Then 5.2 times 8. We have 41.6. Then 8 times 8, we have 64.0. Then 9.2 times 8, we have 73.6. Then 8.4 times 8, 67.2. Then we have 7.2 times 8, that's 57.6. And 5.8 times 8, that's 46.4. And 3.6 times 8, that's 28.8. And 0.6 times 8, that's 6.4. Okay, then we have 1.44 times 18, that's 25.92. Then 4 times 18, that's 72. And 6.8 times 18, that's 122.4. And 9.4 times 18, 169.2. And 12 that's 218 16 14,252 and 10.6 and 190.8 and 4.84 87.12. So these are the values for our W's. What we left to do now is to add them together to get our W total. So our W total now, before we get our W sine alpha, W equals alpha. So let me create a space for alpha here. So this is W total, which is the addition of W1 and W2. Mind you, this is capital letter W, while this other W is the small letter W. So moving on, the first one is 12.8, 12.8, 41.6, 64.0, 190.8, 87.12, 6.4 plus 2, so that's 258.4. 218.16 plus 28.8, that's 2.6.96, 169.2 plus 46.4, that's 215.6, and we have 122.4 plus 57.6 and 180, and that's 72 plus 67.2, 139.2, and we have 73.6 plus 25.92, that's 99.52. So W total 62, 64, 100, 144, 180, 220, 251, 258, 180, and 87. So yeah, same checks. So from here now, we will now decide to measure our alpha. Okay, so for the first one, mind you, this side is going to be negative, while this other side is going to be positive. And from what I'm saying now, I already know that my alpha 3 is going to be 0, because looking at it, it's already on a straight line. So measuring my angles now, for alpha 1, I have about 11. Yes, that's minus 11. Minus 11. So for my alpha 2, I have minus 7. Yeah, minus 7. So that other one is 0. And moving on to alpha 4. Alpha 4 now is 6, 6, 6. Then alpha 5, alpha 5 is about 10, 11, 12, 13. Alpha 5 is 13. Mind you, is in degrees, not radian. And alpha 6, alpha 6 is 26. Yeah. Okay. Mind checking alpha 6 or alpha 7? Alpha 6. Oh, I think I'm checking alpha 7. Alpha 6 is 20. 20, while my alpha 7 is 26. Then alpha 8, alpha 8 is 34. Alpha 8 is 34. Then alpha 9, alpha 9 is 41. 41. Alpha 9. Then alpha 10. Alpha 10 is 50. 50. Then the last one, which is alpha 11. Yeah, alpha 11 is 61.5. 61.5. Yes. So from here now, we get our W cos alpha and W sine alpha. W cos alpha, then W sine alpha, which is going to be the last. And after getting the summation, of course. And speaking about W is W total. W total sine alpha. So back to the calculator. Minus 11 plus 12.8 plus minus 12.8 cos minus 11. And that's 12.56. 12.56. Then sine minus 2.44. 31.6 plus minus 41.29 plus sine minus 5.07. So 64 plus 0 is 64. Wow, 64 sine 0, 0, 64. So 99.52 plus 6, that's 98.97. About sine 10.40. Then we have 139.2 plus 13, 135.63. Sine 31.31 and 180 plus 20 and 69.14 and sine 61.56. So 215.6 cos 26, 193.78. Then sine 94.51. Then 346.96. No, 246 cos 34, 204.74. And then sine 138.10. Next 258.4 cos 41, 195.02. Then sine 169.53. Then 190.8 cos 50 cos 50, 122.64. Then sine 146.16. Okay, we have 87.12 cos 61.5, 41.57. And then sine 76.56. So now doing the summation, that's 12.56 plus 41.29 plus 64 plus 98.97 plus 135.63 plus 169.14 plus 193.78 plus 204.74 plus 195.02 plus 122.64 plus 41.57 equals 1279. 1279.34. 1279.34. Okay, now to the second part. Minus 2.44 minus 5.07 plus 0 plus 10.40 plus 31.31 plus 61.56 plus 94.51 plus 138.10 plus 169.53 plus 146.16 plus 76.56 equal to 720.62. 720.62. Okay, now that we have both values, all we have to do is to substitute and get our final answer. So once again, let's try to list out all the parameters that we have. So according to the question and according to the solution, we've written out this. Then our theta now is 83 from our measurement. Then our radius from our measurement is 18.6. Then our angle of internal friction is 30 degrees. Then our cohesion is 32 kilonewton per meter squared. Then the next thing for us to find is the length of the arc, which is equal to r squared or r theta. So and our theta has to be in radian, so which is going to be 18.6 multiplied by 83 times pi over 180, which will in turn give us 18.6 times 83 times pi and divided by 180. That's 26.94. 26.94 meter. So that means our CL from the equation, our summation CL is going to be 32 multiplied by that answer, 26.94 times 32. So 862.22. 862.22. The unit is going to be in meter squared. Yes. Now, substituting what we have inside the general formula, and the general formula for the factor of safety is equal to summation CL plus tan phi summation W cos alpha, that's W total, divided by summation W sine alpha, which is going to be 862.22 plus tan alpha, that's tan 30 into bracket 1279.34 close bracket all over summation this, that's 720.62. So from here now, our factor of safety will be equal to plus 1030 into bracket 1279.34 close the bracket, then divided by 720.62, that's 2.22. So which is our final answer. So this also was done using AutoCAD software and computed by Excel. So and the answer gotten from that one was 2.3. So what I have here now is 2.22. So they are not far off. So they are still within the range. So you can say this is on the way. You can say it's correct. Thank you for staying with me. See you next Friday. See you next time. Bye bye.